In this video, we are going to talk about how to solve a quadratic equation using the square root method. So, first of all, a quadratic equation is an equation written in the form ax squared plus bx plus c is equal to 0. So typically when we're solving, the goal, we know that a square root undoes something squared. So it's going to undo this squared right here, x squared. But that can only happen if I can isolate this term. I can't isolate x squared if there's also a bx included. So we can only use the square root method when we're missing that bx term. And when we are missing the bx term, we can just isolate the squared term, the x squared, and then undo it using a square root. So let's take a look at an example. In this first example, we have x squared equals 4. So x squared is our squared term, and it's already by itself. We know that we can undo an exponent of 2 by taking the square root of both sides. So if I take the square root of x squared, I know that these are inverses, so they undo each other, and we're left with just an x. And I know that the square root of 4 is 2. However, when we're solving, we are looking for all possible values of x. So I know that if I do 2 squared, I would get 4. But I would also get 4 if I do negative 2 squared. So when we take the square root, when solving, we actually have two solutions, the positive and the negative. Both of these would make our equation true. So now let's look at another example. In this example, we have x squared plus 5 equals 21. Well, our first step is always to try to isolate this squared term. So we need to get rid of this positive 5, so we can subtract 5 from both sides. 5 minus 5 is 0. X squared is equal to 16. And now I can undo that x squared by doing the inverse operation, which is to take the square root of both sides. So the square root of x squared is just x. I know that 4 squared is 16, but so is negative 4. So these would be our two solutions for our original equation. So in this example, we have 5x squared minus 1 is equal to 44. So it's really important that when I look at this, this is my squared term. However, my base is just x. So I need to isolate that piece of it before I can take the square root of both sides. So again, we want to just solve like normal. We're going to undo order of operations by using inverse operations to get there. So this is where I'm trying to get x squared alone. Well, that's 5 times x squared. So to undo multiplication, we can divide both sides by 5. And we end up with 9. Now that I have my squared term alone, I can solve by taking the square root of both sides. The square root of x squared is just x, the square root of 9 is 3, and negative 3. So these would be the two solutions that make this equation true. And the last thing I want to talk about is if I have an equation that looks like this, I'm going to isolate my x squared still. So when I subtract 25 from both sides, I get x squared is equal to negative 25. Well, when I go to take the square root of both sides, I'm all of a sudden taking the square root of a negative number. And as we saw earlier this year, there's nothing that I could square to get negative 25. So because this is not possible with the information that we know at this point in time, we would say that this has no real solution. And I want you to write the word real in there because eventually you will learn that there are solutions, they're just not necessarily real. So that's solving by square rooting.